Alright students, now let's go ahead and see the chemical characteristics of an acid. In the last video we saw the physical characteristic of acid and base. Now let's see the chemical characteristics. So for that we have to react the acid with different components. First we'll react with metal, then with bicarbonates, then with carbonates, then with sulfide, bisulfite, sulfide, metal oxide, and then after neutralization reaction. So let's start and go ahead quickly. Metal. Now here you note one important thing. Alright, do not use in this reaction sodium, potassium, metals because they react violently. So do not use this two metals. Alright. Second thing, when you are giving this example, do not use copper metal. Do not use copper metal because copper cannot displace hydrogen. Copper cannot displace hydrogen. Am I clear? So when I am writing this reaction, please be very much careful that you must not use these 3 or 4 metals because they are highly reactive, and you don't use copper metal because copper cannot displace hydrogen. Alright, this much care must be taken. Now when I react with a metal like zinc, Zn plus say any acid I am taking H2SO4. But here another important thing is when you are using H2SO4, use it as dilute H2SO4. Don't use concentrated H2SO4. Whenever you are performing the chemical reactions of acid, when you are using H2SO4, it must be dilute, it must not be concentrated. So this parameters you must keep in the mind. So now the product is ZnSO4 and that is liberation of hydrogen gas. What is the characteristic of hydrogen gas? That when a burning matchstick is brought near to the mouth of test tube, it burns with a pop sound like a cracker. Alright. Then bicarbonate. Bicarbonate is what? HCO3 minus 1. HCO3 minus 1. So now always remember, whenever you find CO3 this type, CO3 2 minus or HCO3 minus, always liberate CO2 gas. Always liberate CO2 gas. Right? So now here if I take NaHCO3 plus HCl I am taking. HCl can be dilute. It is always dilute only. Now NaHCO3 plus HCl will give me what? Always first liberate carbon dioxide. When you find CO3, always put over here first CO2. And then we are having NaCl and H2O. Similarly, you can proceed ahead with CaHCO3 twice. You can practice more and more by using bicarbonate, but the product will remain same. The salt of the metal, water, and liberation of carbon dioxide. This is fixed. Alright. Then next, carbonate. Carbonate is CO3 2 minus. Now, when you are taking carbonate, I am taking say CaCO3 and I am taking HCl. So first liberate CO2. Then metal chloride. But here Ca means the Ca is plus 2. Alright. It is having the valency plus 2. So I'll need 2Cl minus. So it will form CaCl2. And then after what is remaining is H2O. Alright. So the product pattern will remain same. Salt, CO2 and water. Okay. Now sulfite. Sulfite is SO3 2 minus. So whatever happens with CO3 2 minus, same thing happens with SO3 2 minus. Reaction remembering is very easy. Only difference is say I am taking CaSO3 plus 2HCl. First liberate SO2 in the similar pattern plus CaCl2 plus H2O. Here CO2 is liberated. Here SO2 is liberated. Now bisulfite. Bisulfite is HSO3 minus 1. So here bisulfite I have bicarbonate I have taken sodium. So here also I will take sodium. You can take anyone. NaHSO3, any compound you can take, plus HCl or H2SO4 also you can take. So it will form what? First liberate SO2, then form the salt, NaCl, and liberate water molecule. That's it. The pattern remains same. Now sulfide. Sulfide is S2 minus. Use the sulfide of either zinc or Fe. That is very important. Use the sulfide of zinc or Fe or max to max copper. Alright, when you are writing the example, either of three you can take. So ZnS if you take plus H2SO4 if you take, alright, it will produce H2S gas, rotten egg smell, alright, and plus I'll be having ZnSO4. So this is your observation, liberation of H2S gas which is having rotten egg smell. What is observation of SO2? Turns dichromate paper green. And what is the specialty of CO2? Turns lime water milky. Okay. Now, here I am using metal, pure metal, I am getting liberation of H2. Now, what if I use metallic oxide? Say I am using calcium oxide. So, calcium oxide, when I use, say, copper oxide also. See, you cannot react copper with HCl, but you can react copper with copper oxide with HCl for sure. Copper oxide with HCl, it is black in color. Copper oxide is black in color. When you react with HCl, it produces CuCl2 plus formation of H2O. I'll need 2 molecules of HCl. Right. Now neutralization, it is the easiest reaction. React any acid with any base. Say HCl plus NaOH. What do you get? NaCl plus H2O, salt and water. That is the most famous reactions in chemistry. Am I clear about this? So, you can take the picture also. Fine. So, these are the chemical reactions of acid. Now, let's take the chemical reaction of base, which are very, very simple. Alright, the bases can be oxide, it can be hydroxide. Alright. Now, for neutralization that we have done in acid also, if I take, say for example, CuO plus H2SO4, it gives CuSO4 plus H2O. So, whenever you find the product as salt and water, it is acid and base reaction. That's it. Nothing to worry about it. Now, the reaction with ammonium salt, this is really very, very important. Say for example, NH4Cl I am reacting with say for example NaOH. Now this is really very important. Put a star over here. When ammonium salt react with alkali, alright, there is no exchange of ions. There will be liberation of ammonia gas. This is very, very important. Take utmost care of this. There will be liberation of ammonia gas. Rest salt and water. That is okay, but the important thing is the liberation of ammonia gas. Alright, that is having a pungent smell. Pungent smell of ammonia. Alright, then precipitation reaction. Precipitation reaction is with you can take non-amphoteric salts like FeCl3 you can take. Then with FeCl3 and NaOH, if you react, it forms FeOH thrice plus H2O. I'll need 3 molecules of sorry, not H2O, my mistake. Right. It will form 3 molecules of NaCl. This you have already learned in chapter number 4, that is analytical chemistry. So right now we are not going deep inside it. It will form reddish brown PPT. So it will be same as chapter number 4, that is analytical chemistry. Now the last one, amphoteric salt. Again this is same as chapter number 4, analytical chemistry. Which are the amphoteric ions in your syllabus? You will have Zn, Pb and Al. Alright, so if I take Zn, OH twice and I use NaOH, excess of NaOH with this, it will form Na2 ZnO2. This is exclusively for amphoteric. So it will form Na2 ZnO2 and I'll need here over 2 and there will be liberation of 2H2O. Okay. So these two parts are already the part of your syllabus in chapter number 4, that is analytical chemistry. This is neutralization reaction, and next is ammonium salt, which is very important, where you need to liberate the ammonia gas, right?